Hi, how are you? Fine. Yes, now we are going to discuss simple pendulum. Simple pendulum. First, we are going to discuss simple pendulum. Simple pendulum. Oscillation simple pendulum. Is simple harmonic motion. Simple harmonic motion. Next we will discuss, we are going to discuss time period of simple pendulum. Period of simple pendulum. Time period of simple pendulum. Time period, that is T. Time period of simple pendulum. What's the time period? Time taken to complete one full oscillation. Let us consider this as a simple pendulum. Means it oscillates like this. Like this. Okay. What's the time period? Time period means just a time taken to complete one oscillation. Time taken to complete one oscillation. One oscillation means it starts from here to here, then here, then here, then here. This is one oscillation. Time taken to complete one oscillation. Time taken to complete one oscillation. From here to here, here is one oscillation. Time taken to complete one oscillation is called time period. Now I am going to discuss time period. Okay. For that, let us consider. So, simple pendulum of mass m. Simple pendulum of mass m. The bob of mass m. The length is m. What is here? Length. What is length? Length is nothing but center of mass to this point. Center of mass to this point. Tension is what? T. Acting in upward direction. There is upward direction. The weight is acting in downward direction, that is mg. The weight is acting in downward direction, that is mg. Okay. Now the mg, that's the weight, time period, that is tension. This is called tension. Weight, tension, or same magnitude, opposite direction, then it is in a resting position. I am changing this bob like this. I am changing this bob like this. From A to B. A to B. Do you understand? A to B. Now, the weight is always acting towards the center of the earth. There is no change. In G, there is no change. Weight is acting towards the center of the earth as it is. There is no direction change. Here, this is a tension T, always the string itself. It makes an angle theta. Then this mg can be divided into two components. Horizontal component as well as vertical component. And that component joined to the theta value is called horizontal component. That is a cos function mg cos theta. Perpendicular to this line, there is a function that is mg sin theta. Mg sin theta. That means what we divided. That is mg can be divided into two components, mg cos theta, mg sin theta. Okay, vertical component as well as horizontal component. I don't understand. Okay, let us consider this length of the pendulum. This makes distance x. X is nothing but L into theta. L into theta. This is x. Arc of the circle is nothing but, that is radius as well as product of radius as well as angle it makes. I would understand. Okay. Just repeat. T and mg sin cos theta. T mg cos theta are same magnitude, opposite direction, same line of action. I don't understand. These two are T cos theta, same magnitude, opposite directions, same line. It acts same line. Then what's the thing here? Cancel. There is only one force which is acting mg sin theta. There is only one force acting mg sin theta towards center. That's why I am changing this from here to this. There is a feeling in my hand, it tends to come its original position. There is a feeling in my hand, it tends to come its original position. That means that mg sin theta is acting towards this one. Mg cos theta, tension, cancel. Only one force is acting towards its center. That is nothing but there is a force, that is F. For example, small binomial expression, we can do it. Otherwise, there is a small shortcut. If theta is small, sin theta can be written as theta. Directly we can take it. Or in other ways, we can use the binomial expressions. Okay. Then sin theta is nothing but there is F is equal to mg instead of sin theta, theta. Okay. What? Then here is what? Theta. That is x is equal to what? L into theta. X is equal to what? L into theta. Theta is equal to what? X by L. X by L. Just to substitute this value here. Then F is equal to what? Mg instead of theta, x by L. X by L. I don't understand. Again, this can be written as what? That is F is equal to what? Mg L into x. I don't understand. That is the thing. Here we derived it from this particular format. What's F? F is nothing but ME. F is nothing but ME. That is what? Mg by x into by L into x. M getting cancelled. A is equal to what? G by L into x. This is an acceleration. This is an acceleration. Okay? But what type of oscillation here? Here, this oscillation is simple harmonic motion. Simple harmonic motion. Why this is called simple harmonic motion? What is simple harmonic motion? To and fro. To and fro motion is called simple harmonic motion. To and fro means what? In a fixed point, it is moving here and there. In a fixed point, moving here and there. To and fro. This is called simple harmonic motion. Logical thing. Hello friends. Now we are going to discuss small experimental part on simple pendulum, followed by IIT questions. Entrance questions we will discuss. Okay. Actually, this is a simple pendulum. Simple pendulum of mass, bulk of mass m. Weight is in the downward directions, that is mg. The tension is acting in the upward direction t. This time period, that is t, is called 2 by under square root of L by G. What is T? T is called time period. T is time period. What is called? T is time period. What is time period? Let us consider this single pendulum. This single pendulum. It moves in these directions, then come back to these directions, then return to the same position. The time taken to complete this oscillation is called time period. Time taken to complete one full oscillation. Let us consider this experimental setup. I am oscillating this like this. What is time period? If I oscillate this one from here, this is the from this one 1, 2, 3, 4. This is the time taken to complete this is time period. From here to here, then back, then here. So time period. Time taken to complete one full oscillation. This is called oscillation. One oscillation. Time taken to complete one oscillation is called time period. Okay. L is what? L is what? Length of the simple pendulum. What is length of the simple pendulum? From this point to this point. What is this? This is called center of mass. Center of mass. For example, if you consider this small lamp I am using for oscillation, let it be center of mass. It has one center of mass in its center point. It has a center point here. Let it be this a center. This is a center. This is a center. Maybe this is a center. Then the length is nothing but from this point to that edge. That's the time taken to complete from this point to here is called length. What is G? G is acceleration due to gravity. What is G? G is acceleration due to gravity. Okay. For example, I am giving this is a small experimental setup. Let that is G be the constant. Let G be the constant. Then already this is constant. This is constant. Then T is what? T is directly proportional to the square root of L. Time period is directly proportional to length. Just this can be explained with the help of small experimental setup. For that I am going to measure oscillations. I am going to measure oscillations. Time, that is 10 oscillations. 10 oscillations. Then one oscillation. Then time taken. I am going to find it. I am going to find it. First what? Time taken for 10 oscillation. Time taken for one oscillation. Then time period. This is nothing but a time period. This is nothing but a time period. One oscillation is called time. Time taken to complete one oscillation. Time taken for one oscillation is called time period. This can be measured here. Shall we measure? Okay. Just I am going to try to. For that I am using this cell phone stop clock. Here we are using stop clock. This is stop clock. I am going to use it, the stop clock. First I am going to find the 10 time taken for the 10 oscillation. Then I am going to convert it in a one oscillation, that is called time period. Okay, first I am going to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, there is a time taken. What's the time? Here the time is, you can see. Yes, you can see. There's a 21.95 seconds. 21.95 seconds. 21.95 seconds. Some sort of length. I am not going to change any length at all. I am not going to change any length at all. Now I am going to change the bulb. It's a small size bulb. I am removing this one. I am removing this one. Put another big size. Big size means center of mass goes here. Center itself. Then automatically what will happen? Length will increase. Length will increase. Okay. First we measure, it's a small ball. Small lamp. This is a big lamp. Now I am going to find the time period. Are you able to understand? Again I am going to oscillate it. For that I am using what the thing here. Stop clock I am using here. This is a stop clock. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just see. What's the value? Here 25.23 seconds. Here what? 25.23 seconds. Actually, this is a big ball. This size is big one. This one small one. Then a time period is not here. For 10 oscillation, I counted here. That's one oscillation. One oscillation means that is divided by 10. Divided by 10. That is 2.195. This is nothing but a time period. Time taken for one oscillation is time period 2.195. Here what? 2.523. That is 2.523. What's the thing here? When that's the lamp size increases. Lamp size increases means what? The length is increased. Length is increased. And what's the length? From that point to center of the bulb. Center of the ball. Center of the ball. For the small ball means the center of the ball is raised just above this value. Big ball means the center of mass increased. The length also increased. Then what will happen? This is a length, small lamp. Length is what? That is L1. This is L2. What's the time period? T1, T2. Time period T1, T2. Can you understand? That is L1, L2. L1 is what? The length is 2 point. The time period is what? That is T1, T2. Here the time period 2.195. Here 2.523. That is small. Automatically this is small. Length is small compared to this one. That is L1 less than L2. Automatically T1 less than T2. T1 less than T2. T1 less than T2 means that is L1 less than L2. T1 less than T2 means that is T is directly proportional to L. T is directly proportional to L. When the acceleration due to gravity is constant, since we are using this pendulum here only, not anywhere. There is acceleration due to, if you change the position, the acceleration due to gravity gradually changing. If you bring this one, acceleration due to gravity changing. Okay. If you bring this ball in upward direction from the Earth's surface, the acceleration due to gravity decreases. If you bring this ball below the Earth, if you bring this ball to below the Earth, the acceleration due to gravity decreases. At the center of the Earth, acceleration due to gravity is 0. Over the surface, 9.8. That's we are not changing the positions. That's why G is constant. L only we change. How the L is changed? By changing the size of the ball. Okay, here we must know that the L is nothing but length of the pendulum is nothing but a top here from this point to center of the mass of the body. Okay, and this is the simple experimental arrangement. We must know the concept clarity. For that I put the small video clipping, the experimental setup for the simple pendulum. Okay. Hello, it's the IIT section, IIT problems. IIT, previously I think 2002 this was asked. It's important questions, simple questions as well as important questions. Using this particular topic, that's a simple pendulum. First session we derived the simple pendulum time period. Second session some sort of experimental setup. Third one is we are going to discuss IIT problems. Okay? Yes. I also IIT problem here. A simple pendulum has a time period T1. T1. Time period you know? This is the time taken to complete one oscillation. One oscillation from K to Q, then again K. So time taken to complete one full oscillation. Actually, simple pendulum time period of the simple pendulum is T1. Now the point of suspension. This is a point of suspension. This is a point of suspension. We used to that one. Point of suspension. Point of suspension is moved upward directions. It is moved in upward directions. Already you know, if you change the height of the simple pendulum, automatically what's happening? That is the G value changed, time period is also changed. Here we moved this point of suspension without changing the length. We moved the point of suspension in upward directions. With an acceleration, some sort of acceleration, distance, that is y is equal to k. Y is the upward directions. This displacement in the upward directions. Y is nothing but displacement in the upward direction. K is something 1 meter seconds minus 2. Now the time period is T2. Already, so time period of the simple pendulum is T1. Now it is moved in the upward direction with an acceleration. Y is equal to, with an acceleration, then displacement is equal to kx square. Displacement is kx square. It is moving. Now the time period is, there is a change in time period. Since acceleration due to gravity changes, if you move in upward direction, there is a change in time period. That time period is T2. You know T1, T2. What they asked to find the value of T1 square by T2 square. You know, You must know the form that is the problem clear one. T1 you know, T2 you know. T1 is in a position on the ground. It is moving with the acceleration upward direction. You find T2. T1 square by T2 square, they asked you. That will understand. Okay? Yes, please. Here the formula for the time period T is equal to 2 by under square root of L by G. That is the time period T is equal to 2 by under square root of L by G. Here L is constant. L is constant. Why? We are not changing about length of the pendulum. Just we are moving the whole system. We are moving. This is simple pendulum means we are moving the whole system. We are moving the whole system. That means length of the simple pendulum is constant. Then here is this is also constant. 2 by is all number only constant. That is T is directly proportional to 1 by under square root of G. This is constant. This is constant. T is directly proportional to 1 by under square root of G. Then T1 by T2, T1 by T2. That is G2 by G1 under square root. Under square root. Okay, yes. Then what will happen? T1 square by T2 square is equal to what? G2 by G1. G2 by G1. What is G1? G1 on the floor, on the surface, earth surface. What is G2? When it moves in upward direction, acceleration gravity. Okay. How can you find the G2? How can you find the G2? G2 can be found with the help of this one formula that is given data y is equal to what? Kx square. Dy by dt. Sorry. Dy by dx is equal to what? 2kx. Let's bring the 2 here. Differentiation. Then d square y by dt square is equal to 2k. I don't understand. What is this? This is nothing but acceleration. This is nothing but acceleration. D square y by dt square is nothing but acceleration. A is equal to 2k. K given here 1 meter second minus 2. Then what will happen? That is 2 into 1. That is what? 2 meters second minus 2. This is an acceleration when it is moving in upward direction. Moving in upward direction. Okay? G1 is what? G1, this is a G1, 10 meters second minus 2. Then G2 is what? That is G1 plus what? G1 plus this value plus this acceleration. This acceleration. This acceleration. Then this is what? 10 plus 2. That is 12. Are we understand? Are we understand? Here 10. If it is moving with a particular acceleration, acceleration will be definitely changed. That means what? 10 plus 2. That is what? 12. You know G1, you know G2, you know. Let's just substitute here. Here 12 by 10. That is what? 5 by 2. 5 by 2. 10. This is 12. 12 by 2. That is 6 by 3. 6 by 3. That's the answer is what? That is T1 square by T2 square is nothing but 6 by 2. Sorry. Ready? 12 by 10. 12 is what? This one. 12 is what? G2 is 12. G1 10. Then this is nothing but 1.2. Let it be 1.2. Then this is what? That is nothing but 1.2. This is the answer. I don't understand. That means the time period increased 1.2 times when it is moving at the acceleration 2 meters second minus 2. This is IIT problem. Very simple problem. Only thing is you must understand the concept clarity. Okay. This is the third session. So if time permits, we will discuss more IIT NEET related problems. My opinion is, only thing is, you must clear and thorough on the topic, on the particular topic you are studying. Base concept you must know. Otherwise, it's very difficult to go application point of view. Are you able to understand? Okay. I will discuss more problems and concepts in the forthcoming sessions. For that, what do you have to do? You must do one thing. Just you subscribe this particular channel. It is very useful for you. That is, you can invite more friends in this discussion forum. Then only you can get a more discussion and video concept clarity. You can get it. Just you better to subscribe for better. Okay, subscribe and touch it on that particular. If there is any doubts, you just comment on the comment box. Okay, bye.